extension of what we learned on Monday with determining the exact values. Okay, so really just an extension of what we did, guys, quiet down please, on Monday. So to determine the exact values of any trigonometric ratio where the angle is over 12, then there's addition or subtraction formulas. So you find two angles that add or subtract, it doesn't matter, to the angle that you're looking for. But the important thing is the two angles you choose have to do what? Does anybody recall from Monday? What do they have to do?
They have to be able to
To what?
over 4, 3, or 6.
Perfect. Okay, so you have to be able to reduce them so that the denominator reduces down to a 4, 3, or a 6. You don't care what the numerator is because we can figure out the trigonometric ratio of any single angle that has a 4, 3, or 6 on it by using our related angles, casserole, and all that fun stuff. Okay, anybody give me two numbers that add to 13? That those two numbers would simplify over 12. David? Perfect. Okay, so the tangent of 13 pi over 12 becomes the tangent of 3 pi over 4 added to pi over 3. Any questions on getting those two angles? And again, those aren't the only two angles. Okay, you can use a bunch of different ones, but remember to have to simplify. So from this point, remember, again, a common mistake people make is they're like, this angle here is my special triangle, so they change it to the related angle. You can't do that at this point because you're not accounting for the casserole. Okay, so you have to, as soon as you write it as the sum or the difference of the two angles, then use your formula. Okay, that's what the whole essence of this guide is these addition formulas and subtraction formulas. So the tangent of 3 pi over 4 plus pi over 3 is equal to the tangent of 3 pi over 4 plus the tan of pi over 3. 1 minus the tangent of the first angle multiplied by the tangent of the second angle. Ah. Right from the formula sheet. Okay, it's like tan x plus y is equal to tan x plus tan y. Is that good? Okay, again, you don't have to memorize these formulas at all, right? You just have to know how to use them. So my first question here is I have to figure out each of these questions individually, right? So this is like a question within inside of a question. The tangent of 3 pi over 4. This angle isn't in my special triangles. That's how I know I have to use the related angle and casserole stuff. My first step is to figure out where is 3 pi over 4. What quadrant would that be? Yeah, sure. Quadrant 2. Perfect. So this is the angle I'm trying to figure out the tan ratio for. So now I relate it to one of my angles inside of my special triangle, which is the related angle. What's the size of that one? Yep. Pi over 4. So the tangent of 3 pi over 4 is the exact same answer as the tangent of pi over 4. Now I have to figure out if the answer is going to be positive or negative, and that's where I use the casserole. So in quadrant 2, the only ratio that's positive is sine, and it's reciprocal, so I make that negative. Does that make sense? Okay. Plus, so that's my, starting to figure out the answer for the tangent of 3 pi over 4. I'm adding it to the tangent of pi over 3, which is one of my angles in my special triangles. So I'm just going to draw my special triangles. First one is 1, 1, root 2, and the angle is pi over 4. And the second one, 2, 1, square root of 3, pi over 6, plus pi over 3. So the tangent of pi over 3, the tangent by definition is the opposite side divided by the adjacent side. So root 3 divided by 1 is just root 3. With the tangent addition and subtraction, once you figure out the top ones, the bottom ones are the exact same thing, so you've already figured out those answers. It's 1 subtract the tangent of 3 pi over 4 has now become the negative tangent of pi over 4 times the square root of 3. Okay, so now I can figure out the tangent of pi over 4. My special triangle, opposite side over the adjacent side. 1 over 1 is 1, so that becomes negative 1 on the top, plus root 3. 1 subtract negative, so those two negatives combine to make a positive, and the tangent of pi over 4 is 1. 1 times root 3 is root 3. So if this was a test question on your first page, very typical type of question, this is what I would expect for the answer. You can check it by putting the tangent of 3 pi over 12 in your calculator, writing down the decimal, and then figuring out what this answer is, writing down the decimal, make sure they match. If you want to check it in the back of your textbook or the back of the guide, you have to rationalize. I'm going to show you how to rationalize this, but again, you won't be responsible for rationalizing on your test. 1 plus root 3, the conjugate is 1 minus root 3. I do that to the bottom. I do it to the top. Now it's a matter of expanding and simplifying. Negative 1 times 1 is negative 1. Negative 1 times negative root 3 is positive root 3. Plus root 3 minus 3. And on the bottom, 1 times 1 is 1. The middle terms would cancel out, and root 3 times root 3 is 3. Collecting the like terms on the top, negative 1 minus 3 is negative 4. Root 3 plus root 3 is 2 root 3. And 1 minus 3 is negative 2. And then I look at each term in that expression, the negative 4, the 2, root 3, and the negative 2. All of them are divisible by 2. And in fact, I'm going to get rid of this negative as well. So I'm going to divide all these terms by negative 2. Negative 4 divided by negative 2 is 2. Negative 2 divided by negative 2 is negative 1. And negative 2 divided by negative 2 is 1. And if you want to make it look a little bit nicer, you'd write it like that. Okay, so that's the way that your guide or your textbook may write the answer. They may write it like that as well. Okay, but again, you're not responsible for any of the red part on your test. It's showing you how to do it. Any questions on that? Okay, so let's do the next one. So the next one, I'm going to deal with the reciprocal ratios. And negative angles. So when you're dealing with a negative angle, basically what you want to do is come up with two angles again, that when you add or subtract, you end up with that angle. But when you're doing the addition formulas for either sine, cosine, or tangent, the first angle always has to be positive. So basically all you're going to do is you're going to find a smaller number, subtract off a larger number, because that would give you a negative answer. So what two numbers can I subtract to get negative 1? David? Pardon? Perfect. So 3 pi minus 4 pi, right? Because 3 minus 4 is negative 1, and we don't have to worry about the negative, and this is positive. You always need this first guy to be positive, right? If you would have used 2 minus 3, you get the exact same answer. So then this becomes cosecant of pi over 4 subtract pi over 3. look at your formula sheet. There's no addition or subtraction formula for the cosecant. So which one are you going to have to use?
The sine formula.
Perfect, because it's the reciprocal of the sine one, right? So you'd write this as 1 over the sine. I'm just going to rewrite it for the benefit of your notes. And then expand it using the subtraction formula for sine, and that's the sine of the first angle multiplied by the cosine of the second angle. Subtract the cosine of the first angle times the sine of the second angle. All of these guys are angles inside of my special triangle, so I can just read off my answers. The sine of pi over 4 is 1 over root 2. The cosine of pi over 3, so pi over 3, the cosine is 1 over 2. Subtract the cosine of pi over 4, which is 1 over root 2, and the sine of pi over 3, which is root 3 over 2. Any questions on what I've done so far? Not going too fast or anything? Okay, so now I'm going to combine the two fractions on the bottom. So I get 1 over 2 root 2, subtract root 3 over 2 root 2. Combining the fraction in the bottom, or fractions in the bottom to a single fraction, I get 1 minus root 3 over 2 root 2. So I'm taking a number and dividing it by a fraction. I have to invert and multiply. So 1 times 2 root 2 over 1 minus root 3. And that would be my final simplified answer. And again, to check it on your calculator, depending on how your calculator works, it's probably a good idea to try it before the test. Okay, you can put in 1 over the sine of negative pi over 12, write down that decimal answer, and then figure out what this decimal answer is and make sure they match. So all of these questions, I don't know, for those people who are on this guide, all of these questions, if you do them, you're noticing that all the same numbers are showing up, right? Like root 3s and 2s and 1s. If you're getting any other numbers, or if you're working here and this denominator doesn't match this denominator, you've done something wrong. Okay, so that is the first page of your test. It is going to be find the exact value of the 6 trigonometric ratios, not all 6. I'm going to pick 3 of them, and it's going to be something over 12, and you have to figure out the exact values. Any questions on that? Okay, the next part, which is going to be your second page of your test, is figuring out the exact values when you're given some information about the angles. Buster. Okay, so the next question reads, given that the cosine of angle x, you don't know the size of angle x, cosine of angle x is equal to the ratio of negative 7 over 25. The only information they give you about angle x is it's between pi over 2 and pi. And then they give you information about angle y. They tell you that the tangent of that angle, you don't know what it is is equal to 12 over 5. And they tell you that angle y is between pi or 3 pi over 2 radians. And you want to use this information to determine the exact value of sine x plus y. Right, so you don't know what the angles are, and you can't figure out the angles, right, the exact values. Okay? So the first thing we're going to do is we're going to expand using the addition formula for sine so that we get just individual ratios, right? Because that's what we need to do in order to evaluate. So the sine of x plus y is the sine of x times the cosine of y plus the cosine of x multiplied by the sine of y. So now at least I have it as a product and sum of independent ratios. Okay, can anybody tell me the answers of any of one of those four? Sine of x, cosine of y, cos of x, sine of y. Sure?
Cos of x is negative 7 over 25.
Perfect. He got that because that was given to him. It's the cosine of x is negative 27 over 5, so I plug that in. Okay? I need to figure out the sine of x, the cosine of y, and the sine of y. They didn't give me that information, but they gave it to me implicitly, which means I can use the information they gave me here to figure out these guys. This, by far, is the most important step. If you mess this up, the whole entire page will be messed up. You might as well not even do the page. Okay? The cosine of x is equal to negative 7 over 25, and it tells me x is between these two angles. What quadrant is x lie in if it's between those two angles? Sure? 2. Okay, how does Jordan know that? Because he knows it starts at 0, goes to pi over 2, then to pi, 3 pi over 2, and then back up to 2 pi again. And it told me that it's between pi over 2 and pi. Make sense? Draw your terminal arm somewhere in quadrant 2. Then you're going to create a right angle triangle. The right angle triangle always has to go down or up towards the x-axis. You're always using the x-axis, never the y-axis in any of these questions. Okay? So you draw your little right angle triangle, and then put your angle in the related angle spot. Now use the information that they gave you. They gave you that the cosine is, and remember cosine is negative up here, right? So the cosine is 7 over 25. So the adjacent side for this triangle is 7, and the hypotenuse is 25. Does that make sense? How do I figure out the third side? All right, Pythagorean theorem. Using the Pythagorean theorem, the third side would be 20. So if I read off of this diagram now, I can read off the sine, because the sine is the opposite side over the hypotenuse. I can read off the tangent, which is the opposite side over the adjacent. So the tangent, according to my diagram, is 24 over 7. But that doesn't make sense, because up in quadrant 2, the tangent ratios are always what? This is the cast rule. Tangent ratios are always negative. Okay? The reason that I'm getting it incorrect is I haven't labeled my diagram properly yet. When you are labeling these sides of the triangle, they're actually not sides. You're labeling the distance or the direction that you've gone. Because I've gone in the negative x direction, I have to write that as a negative. Because this is in the positive y direction, that stays as a positive. But then now all that makes sense for the cast rule, because if I figure out the sine is 24 over 25, which is positive. Sine should be positive. The cosine is negative 7 over 25, which is negative. That makes sense. And the tangent is 24 over negative 7, which is supposed to be negative. Okay? But now I can read off any information I want from this diagram about angle x. The sine of x is 24 over 25, so I can plug that in there now. Now I need some information involving y. Before I need that, Rebecca is going to ask. This right here? Yeah, the hypotenuse, right, is always the terminal arm. So it's always a length. It's always going to be positive. The only thing that's going to change is the x's and the y, depending on what quadrant they're in. Okay, whether it's the positive x, negative x. Okay? So try to draw the diagram for this one. Just take a minute while I do the attendance with you guys, and then try to do that, and we'll take it up as soon as I get off the attendance. Because really, this is the most important thing in order to draw the diagrams correctly. Okay, so I'll do this one in blue. Erase this out of the way. So I look, and it tells me that angle y is between pi and 3 pi over 2, which puts it down in quadrant 3. I draw my side to create my right angle triangle, always towards the x-axis. And I put in my angle in the related angle spot. Then I use the information that they gave me to label the two sides. It told me that the tangent is 12 over 5, and the tangent is the opposite side, which would be 12, over the adjacent side, which is 5. Use the Pythagorean theorem, figure out that the hypotenuse is 13, and now I have to check for the negatives. Which numbers are going to be negative? Okay? Both, right? Because I'm in the negative x direction for the 5, and I'm in the negative y direction for the 12. By far, the most common mistake people make on their tests. Okay? So if you want to, when you're writing the 12, 13 test, draw these diagrams, walk up and ask me if they're correct. I'll tell you whether they're correct or not. If it's wrong, I won't tell you how to do it. I'll just say it's wrong. If it's right, I'll say, yeah, consider it. Okay? It's probably a good idea just to ask before you do it, because really, if you mess up these two things, everything else is going to be wrong. So now from here, the cosine of y, here's y, the cosine is negative 5 over 13. And that makes sense, right? Because negative cosine should be negative down in this quadrant. And then the sine, which should also be negative, is the opposite side over the hypotenuse, which is negative 12 over 13. So that's really the hard part, because this part, most of you have a calculator where you can type that in and it'll give you the fractional answer. Okay? If you don't, then you're just going to have to do some math by yourselves to get the answer that this would be negative 120 over 325 plus 84 over 325, which adds to negative 36 over 325. Okay. We'll just do one more. I'll keep the diagrams there. I'll just insert it over here, call it B. And we're going to do the cotangent. Okay, so the cotangent of x minus y. So the cotangent of x minus y, by definition, is 1 over the tangent of x minus y. So really, I'm figuring out the reciprocal of the tangent, the subtraction. Okay? So remember, the tangent addition and subtraction formulas are fractions. So an easier way of finding 1 over a fraction is just flipping the fraction. Okay? So the tangent of x minus y is tan x minus tan y, but I'll put that on the bottom, and I'll put the top the bottom on the top. And that way I just have this one fraction in order to deal with. What I generally see on a test is people writing, and there's nothing wrong with it, but they'll write this, 1 divided, and then they write out the subtraction formula. And then they solve that, which is fine, but it's easier if you just flip it. You don't have to worry about anything. You guys know what I mean by that? Okay. So now once you got that, and you've already done these diagrams you're going to use for the rest of the page. It's just a matter of filling in your information. So 1 plus, and for some reason, and hopefully it's not going to happen, it'll be the first time ever I've taught this course where somebody doesn't do it in class. The tangent of x. The tangent of x is equal to the opposite side over the adjacent side, and I got people writing this. Why do you think they're writing that? Or does that make sense? But I guarantee somebody's going to do it. I guarantee it. Okay? Please don't be that person. Right? Because the tangent of the angle means what side divided by what side. And it's 24 divided by -7, so you lose the tangent part. Because as soon as you write down it as a ratio, it's not a trig question. Okay, so the tangent of a ratio doesn't make sense. Okay, the tangent of an angle makes sense, and it's equal to a ratio. So then, filling in the rest, the tangent of y is 12 over 5. And really, once you've done that and you're able to use SOHCAHTOA, the rest of it is just being able to use your BEDMAS skills. So combining, and a lot of you, like I was saying, have calculators that you can type this right into your calculator. 1 plus 24 divided by -7 times 12 divided by 5 as a fraction, and you'd get the answer -253 over 35. Adding the two bottom fractions, you would get the answer -204 divided by 35. And then you can divide that right in your calculator to get that as an answer. Okay, so then that's what you need to be successful in your first 2 pages of the test and your first 2 sections of your guide. Next week we'll get into solving double angle formulas, which we'll do a little bit of this stuff, and then equations. So